What I want to do today is teach you how to draw Newman projections. So this is a problem that was taken from your handout, and what I want to focus on is drawing number 1. Now here are some simple rules. Rule number 1. We have to pay attention to what the solid wedges and the dashed lines mean. In other words, in this example, this hydrogen and this cyanide group, nitrile group, are on solid wedges. That means they're coming out of the plane of the paper. Likewise, the two OHs that are attached to dashed lines, they are going into the paper. And these arrows that we're looking at are in the plane of the paper. So the backbone of our molecule, starting from here and going all the way here, all of these atoms are in the plane of the paper, which means that those lines are either going straight up from our Newman projection or straight down from our Newman projection. Okay. Rule number 3, if the arrow is pointing to the right, then solid wedges are on the right side of the Newman projection. And likewise, if the arrow is pointing left, then the solid wedge is on the left. All right? And the final rule, rule number 5, that groups in the plane are either straight up or straight down, and you just look at the arrow. If the arrow is below the group is up. Likewise, if the group is pointing down, is lower than the arrow, then the group is down. So if I draw this Newman projection, what I really want to look at are the 3 substituents on that front carbon. And as I can see, the methyl group is straight up. It's above the arrow and it's in the plane of the paper. Likewise, because the arrow is looking right and I put myself in the paper, the H with the solid wedge is on my right, and therefore the OH is on my left. If I now look at the back carbon, I can see that the rest of this molecule is in the plane of the paper, and it is below the arrow, so that means it's down, and I'm just going to use the letter R to describe the rest of the molecule. Again, the CN group, solid wedge, it must be on my right, and the OH, the dash wedge, must be on my left. Another way to check it is if we compare the two groups on the solid wedges, they must be on the same side of the Newman projection, in this case on the right, and they are. I hope this helps in figuring out Newman projections and drawing them effectively. Thanks for watching.